Well, hi everyone, this is Jason Sansusi with the Do No Drones podcast, and I am here at AUVSI Exponential 2025 here in Houston, Texas, and I am sitting down with Logan Jones from SiFly. A little bit about SiFly, because this is something that I actually got excited about. I saw it on LinkedIn this morning, and I'm like, okay, I'm reaching out, because I am intrigued at what you are building and what impacts I believe it can make on the market. So, Logan, welcome to the show.
Jason, a pleasure to meet you. Thanks for having me.
Truly my pleasure. Look, I just want to dive right into it.
Yeah.
And obviously, I'm interested in the Q12, right? I want to talk about the Q12. So, what are some of sort of the key design? Here's what my goal is. Like, I want to understand some of the engineering innovations that you guys have really built into this platform, and sort of what those design features kind of will do for the industry. So if you could talk about just the Q12 and some of its design features and just some of the engineering efforts that kind of went into this, I'm sure the listeners would love to hear about it.
And we'd love to talk about it because there was a lot of work here. Actually, one step before that, if I could,
Please.
is it's almost the why behind it and what target were we aiming at.
Oh, I hate the why.
But here's what it is. People across every industry, they actually want a helicopter.
Fair.
But they want it at a price point in the economics of a drone, and they want it to be as usable as drones are today. So when you look at helicopter missions, the best data that exists for light helicopters actually comes out of public safety. And the top end of the time away from station or on mission is 2 hours. And the limiting factor on that is fuel and pilot fatigue issues. So our whole design objective was we wanted to cross the 2 hours of endurance mark, and we wanted to do it with an electrically powered system. So then it's like, well, then how do you do that?
That was going to be my next question.
Yeah, so it's layers upon layers of optimization and innovation related to producing lift efficiently. So I tend to think of it in two categories. The first category relates to energy management, and the second category is about forward flight. So energy management is you want to hit a target roughly 2/3 of the overall aircraft weight that is made up of your energy source. So to translate that, if you look at the common multi-rotor today, pretty much without respect to make, model, anything, it's in the low 30s. So 30% to 35% of their overall takeoff weight is the batteries. The right answer is 2/3. And so when you look at where we are, we're around 60, just over 60. So right out of the gates, you have twice the available energy that you can convert into endurance. The other thing that goes with that is you want to be efficient in how you use that energy. And the concept here is called disk loading. And what disk loading means is how much weight you're carrying per square foot of swept area. And if you can get that number as low as possible, balanced against the operating condition that you want, it means that you don't hit the batteries very hard. You don't require a massive discharge. And that is good in all sorts of ways. So we've done a lot there. The second category is making these things fly more efficiently. Like if you set out to design a multi-rotor that is less aerodynamic than today's multi-rotors, you probably fail because they're perfectly not great. And so what that means is we've put a lot of energy in to aerodynamic performance and forward flight. Translating it, we've made it so that the aircraft is actually naturally wanting to fly forward rather than naturally wanting to hover. So the changes are things like the blade shape, the wing struts that we have, the offset rotors. You start to layer all of these together, and that's how you get 4x the endurance of the common multi-rotor.
Impressive. And all makes sense. I'm now curious. So I'm going to dive right into a really fun acronym, ROI. So I've definitely done quite a bit of linear inspections, both for oil and gas and for electric utilities. So you mentioned in a sort of a previous interview that monitoring electrical transmission lines offers a dramatically better return on investment due to obviously the Q12's endurance. So elaborate how this affects the ROI for your future customer.
Yeah, I'd actually look at the inverse. So what drains ROI from the use of drones today, and why isn't it more widespread? I think there's a few things. One is, if you only get 30 minutes on a charge, the limiting factor is I have to go to the spot, I only have a fixed amount of time I can capture data, and I have to swap. So these battery swaps drain productive time in the air. They also, from a logistics standpoint, force an operator to carry a wheelbarrow full of batteries, right? The other thing, this is one of the kind of founding premises of the company is that Part 107, I believe, locked in place certain technology decisions, and it locked in competition and market structure. So what do I mean by that is when you have to add, if you want to extend your range at all, you have to add people to the mission. And every person that you add to the mission decreases the return on investment from using it. So what that did is all the OEMs started to just create DJI clones, the same kind of capability. So where we come from is if a customer now has the ability to go to scale and operate at a distance without the logistics complication of batteries, more batteries, without the frequent stops in a mission due to battery swaps, and with fewer people, that is completely different in terms of ROI for their use case. And I think it cuts across every segment.
I completely agree with that. As someone that is frustrated by that, it is a massive limiting factor.
And I think the multi-rotor format is really important because you could say fixed wing achieves some of this. But from a usability standpoint and a flexibility standpoint, you can't just sit and hover with a fixed wing aircraft. They're not as usable.
And I agree with that. And you're still not getting those sort of efficiencies with today's fixed-wing aircraft either. It integrates, it gives more problems sometimes. So I'm going to get into something that I was really interested in talking about. So the platform is very expensive. It's very impressive. Almost that expensive. We're going to get to that. It is very impressive. What are sort of the initial use cases? Because I saw something about DFR. We've talked about that a little bit for public safety. But what sort of initial sensor integrations are you currently targeting for the?
Yeah, sensors are everything in this business.
That's why we fly.
That's why you fly. You don't just fly for fun. You capture data. So in every Q12 that rolls off the line, we will have an integrated 20x optical zoom camera. And that's on a gimbal, and it's in the ball on front if you've seen the picture. And the purpose of that ball is, one, it's IP55, but two, when you're flying forward, especially in a zoomed in condition, you can experience flutter from the wind dragging over the chassis of the camera. So that'll help protect from wind resistance, plus it's aerodynamic. So that's on every edition. We've also integrated the Sony LR1 in a downward facing configuration. We have a multispectral, the Ultim PT. And if I was to say that other than a thermal, which we're working on, we'll have more on that later, then probably the number 2 most requested payload is LiDAR. And the reason is probably obvious to you and your fans, but the ability to go as slow as you need to get the density of point cloud, and our system can carry the weight, it's a pretty nice application. So we're sorting through that integration as well.
That is amazing. Wow, okay, yeah, question answered for sure. And I think those are clearly the most important applications today. You're covering the 4 horsemen of the data collection apocalypse when it comes to drones for sure. Anything else is gravy after that, for sure. So I'm curious about, you have a payload capacity up to 10 pounds. So what else? What else those are some pretty impressive sensors. Let me skip that one, because I think that would cover, so many different applications. And now I am kind of curious, what are the connect? So you have 5G connectivity.
Yep. How
does that work? I understand what 5G is, but how does that work with your?
Yeah, 5G to us, as we view the market, is a very clear answer to beyond visual line of sight. Yeah. In urban and suburban areas, but even all over the country, you're starting to see 5G connectivity. The thing that is a really nice benefit from our form factor, we're a little bit bigger. What that means is that we have far bigger antenna arrays to improve connectivity. So if you look at the platform, the legs of the platform are actually the antenna arrays. And so we have a 4x4 MIMO radio on board, which allows excellent connectivity at range. In fact, our problem is that we see too many towers when we're at altitude, and you can't cause interference between towers. And then we do have a secondary source, which we'll talk more about our plans later this year, but it's a solution we call DroneFi. And again, we're super excited to talk more about this. Probably at the end of the summer, you'll see an announcement of what our overall plans are with DroneFi, but we think people will like it.
Teasing already? I love it.
We just view, if you look at the industry for long-range flight,
Sure.
The limiting factor is your comms link in many of these, right? And I hear it from customers all the time. So what's in our best interest as an industry is to make comms link as trusted and ubiquitous as possible. And so that's a little more of a teaser on what we're doing.
And I appreciate that, because that is definitely some of the things, because a lot of these operational environments, they're in the middle of nowhere.
They are. So you need a
And
backup.
you need something. Yeah, because I could tell you that most of the places I've flown, especially in summertime, they're not hospitable. There's no cells coverage.
Yeah, we call it old school mode. You have to be able to operate in old school mode, and so we'll have more on that.
Okay, no, that's exciting. I won't let you go further on that, and I know you won't anyway, but that is exciting, and that I appreciate that. Everyone will have to stay tuned. We will have Logan back, and we will talk about DroneFi, hopefully before this fall, or hopefully before the commercial UAV Expo. Maybe? Deal? Okay, that sounds awesome. Man, so I just want to give you a little bit of time. Like, I like these short form interviews. Like, I am excited about this. I want to see, so big question, when are these available and how much?
We're gonna release price and availability this summer.
Okay.
But I think the listeners will be pleasantly surprised with price. I've seen a ton of the comments to our video online, and one thing I want to clear up, when we say that we're competitive with certain price targets, it's the enterprise drone market. It's not the consumer end of things, it's the enterprise drone market. And if you look at that category, there's a pretty wide range of pricing.
Yeah.
And what our objective is that when you look at the added endurance, added capabilities, and you can see a price that's relatively familiar feeling with the enterprise drone market, we think that's a really nice buy. And when we announce price and availability, the target for first production runs, I'd say it's close to the end of the year, beginning of the year, but this is what we have to go firm up. Our point of view is, and you've seen it in our rollout, I think that the past 5 to 10 years in the drone industry has been a trail of broken promises. And so us holding price and availability back is not being coy, it's actually trying to have a target and be able to hit it, because we want to demonstrate that we are different than the past from other companies. So
I think it's a big deal. I mean, so a little bit more about my past. I was employee number almost single figures at Precision Hawk when it was getting started. That was the beginning of my commercial drone career. And yeah, it took me, I think it was a few months before I even saw the bird that they were creating. So we were all joking around the office, is this even a thing? Like, this is a thing, right? Okay, just making sure. So, I mean, there could be a lot of hype, there could be a lot of smoke and mirrors, there could be a lot of broken promises, like you said, and I think it is commendable on SiFly's part to kind of honor that, just do it a little differently, right? You've had a lot of people come in front of you that learned a lot of lessons, and I'm glad to hear you're actually learning.
We are listening and learning, and as we've done this rollout, what we've prioritized is getting a demonstration in front of customers as soon as possible. So, it's one of those things that you can't do forever, but I'm literally driving about 5,000 miles a week, and we're demonstrating. And so last week I was Kansas City on Monday, Orlando on Wednesday, Thursday, Atlanta Friday. And for us, it allows us to listen to feedback of customers, but also it helps us kind of dispel that worry that, is this real or not? It's been awesome.
I think that's fantastic. I'll tell you what, so I'm based out of Denver. If you guys make it out that way, you definitely let us know, because we want to do something more intimate when you're in town.
Okay.
It's fantastic. Awesome. Logan, any final remarks that you'd like to share with the audience about SiFly and what's happening in the future of uncrewed aviation?
Yeah, again, I go back to that starting point. We view ourselves competing against helicopters, not really in the same category of drones today. So what does that mean for the future? We have patents and a lot of IP on how we actually scale the platform up to a larger vehicle. And our portfolio, what we're prototyping now, is that next size up, called the Q250, carries a couple 100 pounds. And the way to think about it is the Q12, we think, is probably 70% of the missions for light helicopters. But the Q250 is a direct assault on that mission, and it covers over 90%. And the only thing it won't cover is if you're carrying people. But for every segment that we've looked at, police, fire, search and rescue, into agriculture, that size platform is a meaningful difference on their operations, but at a price point that every operation can afford. So that's our next plan, is scale up.
I am very excited to see how this goes, where this goes, and the impact that it will make in this industry, because it is still, this industry, and I still believe we are still at only about 4, maybe 5% now, after this conversation, of the total potential in this commercial drone industry. So there's still a long way to go. And I think the technologies like this that really move the bar, that really challenge the common accepted knowledge, I think they're more than welcome. They are absolutely necessary. So thank you to the whole team at SiFly for bringing this technology at the right time.
Thank you, Jason. It's a pleasure to meet you, too. Thank you for having me.
Great to meet you as well. Fantastic. All right, until next time, this is Jason Sansucci in the Do You Know Drones podcast, and safe flying out there.